Hello again. We are continuing our discussion on linear equations and linear functions. We're going to talk about arithmetic sequences and what those have to do with linear functions and linear equations. First of all, let's talk about what those are. I'm going to go over some terms and definitions with you. The first one is, what's a sequence? Well, it's just an ordered list of numbers. It's not just a group. I put them in a certain order based on a certain pattern. The terms of that sequence are the numbers that are actually in that set. And then arithmetic sequence, what that actually is, it's a sequence, and the way it's arithmetic is you always start at a number and you always go up by a certain amount or down by a certain amount to get from one term to the next. So you keep adding or subtracting a constant amount to get from one term to the next. And that amount that we keep going up or down by is called the common difference. Okay, so that's what an arithmetic sequence is. The ellipsis is just what I put at the end of the sequence. It's 3 dots. It indicates, it's a notation and indicates that the sequence keeps going on and on infinitely. Okay, so here's some arithmetic sequences or a discussion about them. I've already said it goes up by the same amount. We're going to call that amount the common difference. So let's look at some examples. I've got 4, 9, 14, 19, and 24. So it looks like each term is increasing by 5 to get from one term to the next. So that common difference D, that's going to equal 5. In another sequence, I've got 13, 11, 9, 7, and 5, and it keeps going. So to get from one term to the next, I have to subtract 2 or add -2. So my common difference is going to be -2. Okay? And if there's any variation in that common difference, if it's not common, even in one spot, then the sequence automatically becomes not arithmetic. So let's look at some sequences and determine whether they're arithmetic or not. 4, 7, 10, 13, and 17. Well, everything starts off good. It looks like I'm going up by 3s to get from 4 to 7, 7 to 10, 10 to 13. But going from 13 to 17, I have to go up by 4. So this is not an arithmetic sequence because in one spot, it's not going up by the same amount anymore. Okay, now look at 5 and 11 and 17 and 23 and 29. It looks like I'm going up by 6s constantly. So that is an arithmetic sequence, and the difference between all of the pairs is 6. 3, 6, 12, 24, and 48. There's no common difference at all. It actually looks like I'm multiplying each term by the same thing to get to the next term. That's a different type of sequence altogether. There's a name for that, but we will discuss that later this year. So for now, we'll just say, no, it is not an arithmetic sequence because there's no common difference at all. Okay, so let's find the next few terms. That's another thing I could ask you to do. Okay, so once you know that something is an arithmetic sequence, you can find the next few terms in that sequence. Okay? So let's go through some examples. If I have 15, 11, 7, and 3, then it looks like all the terms are going down by 4. So my common difference is -4. Okay, so I just have to keep doing that, starting with the 3 and continuing the sequence. So if I subtract 4 from 3, I get -1. If I do that again, I get -5. If I do that again, I get -9. So the next 3 terms are going to be -1, -5, and -9. And I could keep going if I was asked to. Okay, here's some more examples. If I have 13, 19, 25, and 31, it looks like I'm going up by 6s. So my common difference is 6. So if I keep doing that, starting at 31, I get numbers like 37, 43, and 49. Now I've got a sequence of 3.12, 4.15, 5.18, and so on. So if I look at the difference between any two terms, it's 1.03. So that's what I need to keep adding, starting at the 5.18. If I do that, I get 6.21, 7.24, and 8.27. Now I've got a list of fractions, 1/6, 1/4, 1/3, and 5/12. And it doesn't look like there's a pattern here, but I'm told that there is. So to make things easier, I'm going to convert all of those so that the denominators are the same and they're all 12s. So 1/6 will become 2/12, 1/4 will become 3/12, 1/3 will become 4/12, and 5/12 can stay as 5/12. So now I can see a pattern in the numerators. They're all going up by 1s, and the denominators are all 12s. So the common difference is now 1/12. So I just need to keep adding that over and over again. So the next few terms are going to be 6/12, 7/12, and 8/12. Some of those I can reduce, so 6/12 can become 1/2, 7/12 can stay as 7/12, and 8/12 can become 2/3. Okay, now instead of finding the next few terms, maybe I need to find a term that is way down the list. Okay, so all I need to do in order to figure that out is know what the first term is, and I'm going to call that A, and I need to know what the common difference is. I'm calling that D, just like I did before. So let's look at the pattern with these terms, just talking in terms of A and D. So the first term is A. That was easy enough. To get to the next term, the second term, I need to add D once. To get from there to the third term, I need to add D again, so I've actually added D a total of twice to get from the first term to the third term. To get from the first term to the fourth term, I need to start at that A and add D again, so now I've added D a total of 3 times, and so on. So hopefully you see a pattern between the term that I'm on and the number that's being multiplied by D. The number that's being multiplied by D is 1 less than the term that I'm on. So we're going to keep that going. If I'm on the nth term then D is going to be multiplied by n minus 1. So for example, if I wanted the 500th term, I would have to figure out what A plus 499D is. All right, here's some examples. If I wanted to find the 10th term of the sequence 5, 7, 9, and 11, I need to know what the first term is. That's 5, and I need to know what the common difference is. That looks like it is 2. So since I want the 10th term, I need to figure out what A plus 9 times D is. Okay, so replace A with 5, replace D with 2, and I get 5 plus 9 times 2. Order of operations means I do the 9 times 2 first, so 5 plus 18 is 23. So the 10th term is going to be 23. Okay, if I wanted to find the 51st term of this sequence right here, I need to know the first term, which is -1. I can read that. And then to get from -1 to -4, or from -4 to -7, or any of the others, I have to go down by 3. So the common difference is -3. So to find the 51st term, I need to do A plus 50 times D. And that's going to give me -1 plus 50 times -3. And that is -1 minus 150. That gives me -151. So the 51st term is going to be -151. Okay, so here's how I write a function for the nth term. We've talked about how the 10th term, for example, would be A plus 9D, the 75th term would be A plus 74D, the 2000th term would be A plus 1999D, so the nth term would be A plus n minus 1 times D. So how do I write that as a function? F of n is going to be some function, and n is going to be the variable. I've already got an n that I'm using, so once I know what the values of a and d are, I can write it like that. A and d will be replaced with numbers, and n can stay as n. So if I have 6, 11, 16, 21, and 26, the first term is 6, and I keep going up by 5, so my common difference is 5. So there's my function right there in generic form. Replace a with 6, replace d with 5, and that's what I get. Distributive property will give me 6 plus 5n minus 5, and then I can simplify the 6 minus 5 to give me 1. So my function is 5n plus 1. Here's some more examples. -4, -12, -20, and -28. My first term is -4, and my common difference is -8. I keep going down by 8s to get from one term to the next. There's my generic function. Replace a with -4, replace d with -8, and that's what I get. Use the distributive property with that -8 and the n minus 1, and I get -4 minus 8n plus 8. Simplify, and I get the function is equal to -8n plus 4. So that's a way of finding out the nth term really easily, just by plugging in n into that expression. Now I've got 2/3, 1, 4/3, and 5/3. So the first term is 2/3, and the common difference is 1/3. I keep going up by 1/3. There's my formula again. Replace a with 2/3, replace d with 1/3, use distributive property, this is what I get, and it simplifies to f of n equals 1/3 n plus 1/3. So if you know the term number you want to get, you plug that in for n, and you can figure out what that term actually is. 1.23, 4.45, 6.67, 10.89, same thing. The first term is 1.23, the difference is 3.22. There's my formula. Plug in a as 1.23, plug in d as 3.22, distributive property with that 3.22 times n minus 1, and that's what I get. Simplify the 1.23 at the beginning and that -3.22 at the end, and I get that function right there. So you kind of see the pattern of where this is going. You do it enough times, it becomes really easy. So if I were to graph that, I need the function in order to do that, which is why I talked about the function first. So if I have this sequence, -1, 3, 7, 11, and 15, then I'm going to use ordered pairs of n and then what the nth term is. So n will start at 1 and go up by 1s, and the nth term will be all those numbers in the list. So here's what the table looks like. I've got n in the first column and then what the terms are in the second column. So the ordered pairs are each row put in parentheses, 1, -1, 2, and 3, and so on. So if I graph those, that's what it looks like. And if you graph them, you'll see that they line up. If you were to draw a line, it would go through all of those points very, very nicely. Here's another example. If I have 2, 2.3, 2.6, 2.9, and 3.2, the ordered pairs are start at 1 and go up by 1s, and then the nth term is just all those terms that you were given, 2, 2.3, 2.6, and so on. So there's my table, and then the ordered pairs are every row of the table put in parentheses, 1 and 2, 2 and 2.3, and so on. And then the graph looks like this. So again, I mean, they're kind of squashed down a little bit, but you can see that if you were to draw a line, it would go through all of those points. So those points, those ordered pairs, actually line up. So that's kind of how arithmetic sequences tie into linear equations and linear functions, because if you were to graph them, you would always get a straight line if you join all those points together. So that's kind of this big lesson in a nutshell. If you have any questions, please let me know, and I will see you tomorrow.